Imagine looking up at the night sky, the moon shining peacefully as it always has for billions of years. Now imagine this, a rock the size of a skyscraper, hurtling silently through the darkness of space, with a small but very real chance of colliding with the moon in the year 2032. This is not the plot of a Hollywood film or a scene from a science fiction novel. It is a scenario currently being studied by astronomers, physicists, and even space defense experts at NASA and other agencies. The object in question is called Asteroid 2024 YR4, and although its probability of striking the Earth has been ruled out for now, scientists say there is around a 4% chance it could smash into the lunar surface. And here's the twist. In preparation, some researchers are even considering extreme measures, like the use of nuclear technology, to prevent a cosmic chain reaction of consequences. But why does this matter to you, to me, to all of us here on Earth? After all, the moon is not our home. It has been hit countless times before by smaller asteroids, leaving behind the craters we can still see today with the naked eye. However, the size, speed, and timing of 2024 YR4 raise completely new questions. Could a collision on the moon send dangerous debris hurtling toward Earth, threatening satellites, communications, and space stations? Could we witness meteor showers unlike any in recorded history? And most importantly, are we ready to stop such a scenario if it becomes likely? This video is not just about one asteroid. It is about the bigger picture, how humanity is beginning to grapple with the reality that the solar system is not empty, and our technology, our safety, and even our survival can depend on how well we prepare for threats beyond our atmosphere. What you are about to hear is grounded in real scientific data, peer-reviewed studies, and statements from agencies like NASA. This is not a rumor, not a piece of clickbait speculation. It's a case study unfolding in real time that shows just how vulnerable our cosmic neighborhood can be. Now, let me set the stage. In December 2024, astronomers scanning the skies made a new entry into their catalogs, Asteroid 2024 YR4. At first, it was just another dot of light moving differently from the background stars. But within days, calculations began to suggest that its orbit might one day bring it dangerously close to Earth and its natural satellite, the Moon. Headlines began to circulate. Newly discovered asteroid could threaten Earth in 2032. While the immediate danger to Earth has since been ruled out, the story didn't end there. The numbers began to shift, and soon, attention turned to the Moon, a celestial body we often take for granted as unchanging and eternal. Suddenly, that same moon looked far more fragile. And here's the real kicker. While scientists are not predicting global catastrophe, the stakes are still incredibly high. A collision of this scale on the moon could blast billions of kilograms of dust and rock into space. Some of it could be harmless, drifting out into the void, but some could intersect Earth's orbit, potentially damaging satellites, interfering with GPS and communications, and even creating a dazzling but dangerous meteor storm in our skies. In other words, a lunar impact may not kill us directly, but it could reshape the way we live in the space age. Think about it. Every time you use your smartphone for maps, check the weather forecast, or watch live TV, you are relying on satellites orbiting high above the Earth. These satellites are already threatened by natural debris, space junk, and collisions like the one dramatized in the film Gravity. Now imagine adding a sudden wave of high-speed lunar debris to the mix, hundreds of thousands of projectiles racing through near-Earth space. That's the nightmare scenario experts are worried about. But what makes this even more fascinating and chilling is that humanity is for the first time openly discussing radical interventions. We're not just talking about nudging asteroids with spacecraft, as NASA successfully tested with the DART mission in 2022. We're talking about nuclear-scale solutions, explosions in space designed to deflect or destroy the asteroid before it ever gets near the moon. Such discussions raise questions far beyond science. Are we prepared to set off nuclear devices outside Earth? What about the risks if we miscalculate? Could we end up making the problem worse instead of better? This is why today's story matters. It's not just about a rock in space. It's about how prepared we are for threats that don't come from other countries, or even from Earth itself, but from the cosmos. It's about whether we can act as one planet to defend ourselves against forces that care nothing for our borders, our politics, or our technology. And it's about asking the big question: what will we do when, not if, the next asteroid threat comes? Over the next 15 minutes, we'll explore the discovery of Asteroid 2024 YR4, the science behind its trajectory, what could happen if it collides with the Moon, and the extreme methods scientists are considering to prevent disaster. I promise you this: by the end, you'll see the Moon, the sky, and humanity's place in the universe in a completely new light. This is not just space news, it's a window into our future as a species. So buckle up, because this is one cosmic story you don't want to miss. And remember, this isn't science fiction. This is happening right now. Back in December 2024, the world's attention briefly turned to a new discovery in our skies, an asteroid designated 2024 YR4. At first glance, it was just another catalog entry among the thousands of near-Earth objects scientists track every year. But quickly, something unusual stood out. Early orbital calculations suggested that this rock, estimated at about 50-70 meters across, could potentially cross paths with Earth or its cosmic companion, the Moon, in the year 2032. The news spread fast, and for good reason. This wasn't just a small pebble drifting harmlessly through space. A rock that size, moving at tens of thousands of kilometers per hour, carries energy equivalent to millions of tons of TNT. In other words, it had the potential to be a city killer if it ever struck Earth directly. The initial fear was Earth impact. For decades, scientists have warned about the danger of asteroids too small to be tracked early, but large enough to cause serious regional devastation. The 2013 Chelyabinsk meteor, which exploded over Russia with the force of 30 Hiroshimas, was only 20 meters wide. 2024 YR4 is at least twice that size, making its potential impact exponentially more powerful. Early models placed the chance of Earth collision at around 3%. While 3% might sound small, in the world of planetary defense, it's uncomfortably high. Remember, a 3% chance of an event that could destroy a city of millions is not something anyone can shrug off. As more telescopes observed the asteroid, including data from the powerful James Webb Space Telescope, scientists refined their calculations. Gradually, the probability of Earth impact dropped close to zero. Relief spread among the scientific community and the public. But then came a twist. Although Earth was out of danger, the Moon was still on the table. In fact, updated calculations showed a 4.3% chance that 2024 YR4 could collide with the Moon on December 22, 2032. On a cosmic scale, 4.3% is shockingly high. For comparison, most tracked near-Earth objects have probabilities far smaller than 0.01%. This meant the Moon, a body we often see as permanent, reliable, and unchanging, was suddenly facing a real threat. Why does a lunar impact matter? First, let's put things in perspective. The Moon is covered with craters from billions of years of asteroid strikes. But most of those impacts happened long before humanity existed, and none of them were tracked in advance. This time, we can watch it play out, predict outcomes, and even consider responses. That changes everything. A modern impact could produce ejecta, rocks and dust blasted into space, that threatens satellites, spacecraft, and possibly even Earth itself. Unlike Earth, the Moon has no atmosphere to slow incoming debris, meaning any strike is a pure, high-energy collision with maximum material thrown into space. So, when scientists realized 2024 YR4 might not hit Earth but instead slam into the Moon, their focus shifted from relief to concern. Could fragments from a lunar impact create chaos in Earth's orbital environment? Could they pose risks to astronauts living and working on the planned Artemis lunar bases in the 2030s? Could our reliance on satellites for communications, navigation, weather, and defense be disrupted by clouds of lunar debris crossing their orbits? These were no longer theoretical questions. They were being asked in scientific papers and even discussed at planetary defense conferences. The risk assessment process is ongoing. As of the latest projections, the asteroid has a roughly 1 in 25 chance of colliding with the Moon in 2032. If it misses, it will simply continue on its orbit, drifting harmlessly through space. But if it strikes, we will witness one of the most dramatic astronomical events in human history. An explosion visible from Earth, a new crater etched into the lunar surface, and potentially years of fallout for our satellite-dependent civilization. That is why agencies like NASA and the European Space Agency are watching 2024 YR4 so closely. Even if the risk seems modest now, the consequences of ignoring it could be enormous. In this act, what we're really seeing is the shift from asteroid as an Earth threat to asteroid as a lunar threat. And that's important because it expands the definition of planetary defense. It's not just about saving lives on Earth anymore. It's about protecting the infrastructure, satellites, and space stations that form the backbone of our global society. Humanity's footprint now stretches beyond Earth's surface, and so do the risks we face. 2024. YR4 is a wake-up call. The moon is not immune, and neither are we. Let's imagine the scenario. It's December 22, 2032, and after years of tracking and speculation, Asteroid 2024 YR4 finally reaches the end of its orbital journey. Instead of gliding safely past, it collides directly with the moon. What would we see? And more importantly, what would it mean for Earth? The moon has no atmosphere. That single fact makes a world of difference compared to impacts on Earth. When asteroids enter Earth's skies, friction with the atmosphere creates a blazing fireball, and in many cases, smaller rocks break apart before reaching the ground. The moon, on the other hand, offers no resistance. An asteroid traveling at nearly 25,000 kilometers per hour slams straight into the lunar surface, converting its colossal kinetic energy into an explosion of heat, light, and shattered rock. Scientists estimate that if 2024 YR4 were to hit the moon, the blast could unleash energy equal to 6.5 megatons of TNT. That's hundreds of times larger than the Chelyabinsk event, and while still smaller than Earth's dinosaur killer asteroid, it would be among the most dramatic lunar strikes humanity has ever witnessed. What would it look like from Earth? Observers under clear night skies might see a sudden flash of light on the lunar surface, bright enough to rival stars. Through telescopes, the explosion could appear as a glowing plume spreading outward, with new material ejected high above the surface. Within minutes, a fresh crater, perhaps a kilometer wide, would scar the lunar surface. Unlike Earth, where erosion quickly erases scars of the past, this crater would remain visible for millions of years, a permanent marker of the year 2032. But the real story isn't just the new crater, it's the debris. A strike of that magnitude would blast 100 million kilograms of lunar rock and dust into space. The larger fragments would arc into new lunar orbits or fall back to the moon's surface, creating secondary craters. The smaller ones, though, are the real concern. Pebble-sized fragments could escape the moon's gravity entirely, drifting into the Earth-Moon system. Depending on their trajectories, some might rain down on Earth's upper atmosphere as meteors, while others could become a cloud of debris encircling our planet. The visual spectacle of a meteor shower might sound beautiful, but the practical dangers are serious. Even fragments just a few millimeters wide can damage satellites traveling at orbital speeds. In low Earth orbit, satellites and the International Space Station could be at risk of impacts, threatening communications, weather forecasting, GPS, and even astronaut safety. Higher up, satellites in geostationary orbit could also face hazards from drifting debris clouds. The nightmare scenario would be if fragments created a chain reaction known as the Kessler syndrome, where collisions between satellites produce even more debris, exponentially worsening the problem. And then there's the human factor. By the 2030s, NASA's Artemis program and other international space agencies plan to have lunar bases, potentially with astronauts living on the moon itself. A strike by 2024 YR4 would be catastrophic for any nearby installations. Even if the asteroid struck far from a base, shock waves transmitted through the lunar ground and showers of secondary debris could threaten habitats and equipment. Future lunar mining operations, communication relays, and scientific observatories would also be at risk. Suddenly, the moon would no longer seem like a safe stepping stone for humanity's expansion into space. It would look fragile, unpredictable, and dangerous. What about Earth's atmosphere? Thankfully, the asteroid itself poses no direct danger to life on Earth if it strikes the moon. The debris that escapes lunar gravity and reaches Earth would mostly burn up harmlessly as shooting stars. But the long-term consequences for technology and infrastructure could be enormous. Imagine losing access to GPS navigation, weather prediction, or global internet services for months or even years. In our modern, interconnected world, those services aren't luxuries, they're lifelines. Disruption could ripple through economies, defense systems, and daily life. The psychological impact shouldn't be underestimated either. Humanity has always looked to the moon as a stable, unchanging presence in the night sky. To suddenly see a massive fresh scar, a reminder of a violent event we all witnessed, would leave a deep cultural and emotional imprint. It would remind us that our place in the universe is precarious, and that cosmic threats aren't science fiction. They are real, measurable, and sometimes uncomfortably close. So, if Asteroid 2024 YR4 strikes the moon, the event will be historic, visible from Earth, and filled with consequences both inspiring and frightening. We would gain scientific data of immense value, but we might also face years of dealing with the fallout, literally and figuratively. And that's why scientists are so focused on the possibility. It's not about the moon alone, it's about what a lunar strike means for all of us here on Earth. If Asteroid 2024 YR4 were confirmed to be on a collision course with the moon, or worse, Earth, the obvious question is, can we stop it? This is where science, engineering, and even politics collide with cosmic danger. Humanity has been preparing for this scenario in theory for decades, but the reality of carrying out such a mission would be far more challenging. The first and most important factor is time. Detecting an asteroid years or decades before impact gives us options. If we discover the threat only months in advance, our hands are tied. With enough warning, however, we can change the asteroid's path using surprisingly gentle methods. A spacecraft nudging it with constant thrust, or even the gravity of a nearby satellite acting like a tractor, could shift its orbit just enough to miss its target. In the vacuum of space, tiny nudges add up to enormous changes over long distances. NASA's DART mission in 2022 proved this concept. By slamming a spacecraft into the small asteroid Dimorphos, scientists successfully altered its orbit. It was the first real-world test of planetary defense, and it worked better than expected. Extrapolate this to 2024 YR4, and the lesson is clear. If we know early enough, deflection is possible. A similar impactor mission, scaled up, could push YR4 slightly off course, so that instead of striking the moon, or Earth, it harmlessly sails by. But what if time is short? What if the asteroid is discovered only a year or two before impact? That's when more dramatic options enter the conversation, including the most controversial: nuclear explosives. Movies like Armageddon popularized the idea of blowing up an asteroid, but the real science is different. Scientists don't want to shatter an asteroid into countless fragments, which could make the situation worse. Instead, the goal would be to detonate a nuclear device near the surface, not inside it. The intense burst of energy would vaporize part of the asteroid's surface, creating a jet-like push that nudges it off course. This method is risky, politically sensitive, and fraught with unknowns. But in a short warning scenario, it might be the only option. Another possible approach is the use of kinetic impactors on steroids. Instead of one spacecraft, imagine a fleet of them, each delivering high-speed impacts. Coordinated strikes could shift the asteroid's velocity enough to make it miss. This method has the advantage of being less controversial than nuclear use, but it requires precise timing, international cooperation, and massive funding. Some scientists propose more futuristic solutions. For example, a solar sail could be attached to the asteroid, using the pressure of sunlight itself to slowly alter its orbit. Others suggest focusing high-powered lasers to heat one side of the asteroid, creating thrust through sublimation. These ideas remain experimental and untested, but they represent the creativity humanity might one day need. The moon strike scenario adds a wrinkle. Deflecting an asteroid headed for Earth is urgent and non-negotiable. Deflecting one headed for the moon is less straightforward. After all, The moon has no atmosphere, no cities, and no natural ecosystems. Some might argue that letting the asteroid strike could provide valuable science without threatening life. Others would counter that the risks to satellites, space programs, and human psychological security make deflection worth the cost. This debate would almost certainly unfold on the global stage, with scientists, politicians, and the public weighing in. That raises another crucial point: international cooperation. No single country owns planetary defense. An asteroid on a collision course with the moon or Earth threatens everyone. Stopping it would require nations to share data, resources, and technology, setting aside politics for survival. But history shows that cooperation is never guaranteed. Would rival superpowers agree to share nuclear technology for a joint deflection? Would wealthy nations fund the mission while others protest being left out? The politics of asteroid defense might be as complicated as the engineering itself. Public communication would also play a decisive role. Imagine NASA or the European Space Agency announcing that an asteroid could hit the moon, or worse, Earth, in 10 years. How would people react? Some might panic, others might dismiss it as fear-mongering, and conspiracy theories would almost certainly flourish online. Managing public trust while coordinating a global defense strategy would be one of the greatest challenges humanity has ever faced. From a technical standpoint, the biggest uncertainty is not the method, but the asteroid itself. Asteroids come in different types: rocky, metallic, or even rubble piles, loosely held together by gravity. A kinetic impactor that works perfectly on one might fail on another. A nuclear push might cause unexpected fragmentation. Before we could even plan a deflection mission, we'd need reconnaissance spacecraft to fly by 2024 YR4, map its surface, measure its mass, and analyze its composition. Only then could engineers design the right solution. That takes years. Yet another reason why early detection is everything. So, could we stop Asteroid 2024 YR4? The honest answer is maybe. With enough warning, yes. With short warning, it becomes a desperate gamble. And that uncertainty is precisely why scientists stress the importance of funding asteroid detection and defense now, before we face a crisis. The moon strike may be hypothetical, but the broader lesson is real. Earth does not have a planetary defense system fully in place. We're not ready. But we could be, if we act. In the end, the story of Asteroid 2024 YR4 isn't just about science. It's about humanity's ability to look beyond national borders, beyond short-term politics, and to unite in the face of a cosmic challenge. Whether through gentle nudges, kinetic strikes, or the nuclear option, stopping an asteroid would be the first time in history we consciously shape the destiny of our planet. It would be humanity's coming of age in the cosmos. As we reach the final act of this story, let's step back and look at the bigger picture. Whether Asteroid 2024 YR4 ever strikes the moon or even Earth, the true lesson is that humanity now stands at a crossroads. We live in an age where we can track asteroids across millions of kilometers, send robotic missions to nudge their paths, and even dream of one day colonizing other worlds. Yet at the same time, our defenses are incomplete, our cooperation fragile, and our sense of urgency often lacking. The asteroid threat forces us to ask a powerful question. How prepared are we for the universe's surprises? First, there's the matter of preparedness and investment. Asteroids don't follow human calendars or political cycles. They don't wait for us to balance budgets or resolve debates. They move according to the timeless clockwork of orbital mechanics. If we want to protect Earth and the Moon, we can't afford to act reactively. We must detect these objects early. That means expanding telescopes on Earth, launching dedicated asteroid-hunting satellites, and building international systems for sharing data. Early detection gives us decades of time. And with decades, deflection becomes a manageable engineering challenge instead of a desperate last-minute gamble. Without detection, we risk being caught off guard by a cosmic visitor. Second, we must recognize the importance of cooperation. An asteroid heading for the Moon, or Earth, is not a national problem. It's a planetary one. The shockwaves of an impact wouldn't respect borders, and the consequences of losing satellites or lunar infrastructure would be felt worldwide. That means nations need to share not only data, but also technology, funding, and strategies. The Asteroid Defense Challenge is a chance for humanity to practice unity on a scale larger than anything before. History may one day record that the first true global collaboration wasn't about war, but about saving our shared home from a rock in space. Third, this scenario highlights our fragility in space. The moon, often romanticized as a serene guardian in the night sky, is in reality a vulnerable target. The same is true for our satellites, space stations, and future colonies on Mars. The asteroid threat reminds us that venturing into space isn't just about exploration, it's about resilience. We need to design habitats that can withstand impacts, create redundant systems for communication, and develop backup networks that can operate even if parts of our infrastructure are damaged. The dream of becoming a multi-planet species isn't just about ambition, it's about survival. Then there's the psychological and cultural dimension. If Asteroid 2024 YR4 struck the moon, it would be a shared human moment unlike any in history. Billions of people might watch the flash with their own eyes. For generations, people would look up and see the scar on the lunar surface, a permanent reminder of cosmic vulnerability. Culturally, it could spark fear, but also awe. It might inspire art, literature, and new movements dedicated to science and space. Just as the Apollo missions reshaped human identity, a lunar asteroid strike could unite us in humility, reminding us that we are a small species in a vast, indifferent universe. But perhaps the most profound lesson is this: we have the ability to act. Dinosaurs had no telescopes, no rockets, no planetary defense programs. When their asteroid arrived 66 million years ago, they had no chance. Humanity is different. For the first time in Earth's history, a species has the power to anticipate and prevent a cosmic disaster. That responsibility is both terrifying and inspiring. We can't control the cosmos, but we can shape how it affects us. Looking to the future, the path is clear. We need funding for planetary defense, not just as an afterthought, but as a central pillar of space exploration. We need education, teaching future generations not only the risks of asteroids, but also the opportunities they present. After all, asteroids aren't only threats, they're also rich in metals and resources. Mining them could one day support space colonies and reduce the need for destructive mining on Earth. By preparing for the danger, we might also unlock extraordinary opportunities. Finally, we need public engagement. Planetary defense shouldn't be a niche scientific field hidden in technical journals. It should be part of global awareness. People need to know why telescopes scan the skies, why missions like DART matter, and why headlines about asteroids aren't just clickbait, they're warnings. A well-informed public is less likely to panic and more likely to support the international cooperation needed to act. So, what does the story of Asteroid 2024 YR4 really tell us? It tells us that the universe is not static. It's alive with motion, filled with objects crossing paths in ways both beautiful and dangerous. It tells us that threats can come not only from Earth itself, but from beyond. Most importantly, it tells us that humanity is standing on the edge of a new chapter. The chapter where we choose to take responsibility for our place in the cosmos. If we rise to the challenge, Asteroid 2024 YR4, whether it strikes, misses, or simply passes by, may be remembered not as a disaster, but as a turning point. The moment humanity realized that cosmic threats demand cosmic unity. The moment we stopped seeing space as something out there and started treating it as part of our home. The moment we accepted that protecting Earth, the moon, and our future is not just possible, but necessary. And so, as we look to the skies, waiting to see if 2024 YR4 will pass safely or make history, the real story isn't just about the rock. It's about us, our choices, our courage, our readiness to face the infinite. Because in the end, the universe will keep moving. The question is whether humanity moves forward with it, or waits for the next asteroid to remind us what's at stake.